Okay, hello cloud gurus. How y'all doing? This chapter is on cost management. Now, cost management is one of those items that can appear across any question, but specifically in the exam, there are some call outs around managing costs and best practices in multi-account scenarios. And of course, cost control is its own domain by itself. So it definitely is featured fairly prominently on the exam, just like the old exam. The new exam has plenty of cost components in it. So let's get started. Let's talk about some concepts in costing. I want to introduce you to two terms if you haven't heard these before. One is capital expenses and the other is operational expenses. And sometimes people abbreviate this by saying CapEx and OpEx. A capital expense is money spent on a long-term asset like property, equipment, specifically maybe a data center or computers or laptops or something like that. An operational expense is something that a business spends money on just to keep the business running. And it's usually considered a variable expense, meaning they can choose to scale back and pay less or use more and pay more. Now let's look at a very common budgeting cycle for an IT shop. And for a typical IT shop, the budgeting cycle many times centers around depreciation. And this is a accounting concept that allows for companies to spend an expense, a large expense, over time, say several years. Now, accounting standards may differ, but usually companies decide how long they want to depreciate an asset. And let's say in this case, it's 5 years. So as a CIO, I might only get to make a big purchase every 5 years. And because these numbers, these purchases are usually very large, there's a lot of work and a lot of scrutiny that goes into that particular budgeting ask. One of the most difficult things that I have to try to do is predict what needs my internal business partners are going to have over the course of the next 5 years. And then I usually build in extra capacity into my present day budgetary ask to accommodate that. The problem is that most of the time that is a complete guess. My internal business partners might barely know what's going to happen in the next 12 months, let alone the next 5 years. And so many things can change in those 5 years, like the economic market, competition, regulation, technology advancements, and so on. But I don't really have a choice. I only get one chance every 5 years to make this purchase. Now, ideally, my forecast of IT assets might look like this. It's gradually consumed over the years, and my costs are more or less fixed, whether I use the capacity or not. Or it might also look like this if certain projects are canceled. Now I'm sitting on a lot of aging excess IT assets where the organization could have better spent that money on maybe marketing or research and development. Or my capacity might look like this, where demand outpaces my capacity and I guessed wrong. And then in these cases, I might have to do emergency purchases. And because these are one-off, I'm likely not going to get the benefit of some economies of scale in a negotiation for a large purchase. And I'm probably going to end up with different models of equipment, which is probably going to drive up my cost of ownership. Now, in comparison, an OpEx cost model makes use of variable costs. And I buy the capacity as I need it. And if demand goes down, I stop using those resources and stop paying for those resources. This is one of the benefits of pay-as-you-go cloud computing. Now, there are some providers who call themselves cloud providers, but their business model is such that they want to get a 3 to 5 year contract in a fixed fee basis. And that almost mimics CapEx. These companies are more like hosting providers or co-location partners. And that's different. That's not what I'm talking about here. Specifically, I'm talking about the pay-per-use models of AWS, Azure, and Google Cloud Platform, for example. Now, two costing terms you're going to hear about frequently, if you haven't already, is total cost of ownership and return on investment. Total cost of ownership is just a comprehensive look at the entire cost model of a given decision. And it includes generally the hard costs, but also the soft costs. Return on investment is I'm going to give you a certain amount of money, and this is the amount of return I can expect to receive back. Now note that return on investment isn't necessarily always a positive. Maybe it's just a break even, or maybe it's less of a loss than I would if I hadn't invested that money. But when you're talking about these terms, be very, very careful because in the immortal words of General Akbar, it's a trap. The reason is that many times organizations don't have a good handle on their full on-prem data center costs. And this includes stuff like power and cooling and fire suppression and just the real estate involved in supporting a data center. And soft costs are rarely tracked or even really understood. A lot of companies don't really pay much attention to the soft costs. And what I'm talking about soft costs here is the difficulty or the overhead or the extra time that it requires to maintain something. And a lot of times that's just kind of rolled into headcount or subscriptions or something like that. And when we talk about migrating to the cloud, the learning curve is going to be very different from person to person. A lot of times companies don't give this learning curve enough respect or enough runway for people to get fully up to speed. So when you initially move to the cloud, it's very likely that your expenses and time required is going to be much higher than it was in your on-prem world because people were very familiar with that world. And so there's a degree of inefficiency that has to be worked out so that you realize some of those benefits in the long run. Now, business plans usually include a lot of assumptions, which in turn require other assumptions, which in turn require other assumptions. And a lot of times support organizations like IT are several layers down on that assumption chain. So for example, the business plan may say that we're going to go to market with a new business model and we expect to earn maybe $3 million in sales the first year. But it requires a total overhaul of our e-commerce system before we can introduce that new business model. So therefore, as a CIO, I must assume that the e-commerce project is on the critical path and budget accordingly. Therefore, the IT infrastructure team has to budget for new hardware to host the project landscape and maybe some additional headcount to manage it. But if the market conditions change and the company decided to delay the new business model, that easily messes with all the IT assumptions that I've built into my plan. My suggestion overall is don't go it alone. Unless you're a finance person or you have a finance degree and you know that world very well, get help from your folks in your accounting and finance department to help build a TCO and ROI that is based on fact and can stand up to the scrutiny of many of your other business partners. Let's talk about some cost optimization strategies, and we're going to cover 6 strategies here. So the first strategy is just appropriate provisioning, and this is kind of what it seems like. We're just going to provision the resources that we need and really nothing more. Now, this seems simple, but there's many cases where I personally have left instances running when I didn't really need to. And that's one of the things I can do to reduce my costs is just be aware of what's running, why it's running, and shut down the stuff that I don't need. Sometimes I can consolidate for greater density. For example, if I have a bunch of DynamoDB databases, they all have a minimum provisioning read and write capacity. I can maybe consolidate those into one big DynamoDB database and then take better advantage of those read-write capacity units than I was when I was dealing with small databases. CloudWatch can help me by monitoring the utilization of my resources. And if I realize that some of my instances aren't being very highly utilized, maybe I can scale them back. Okay, so in this case, we have 4 DB-T2 small multi-AZ databases, and that's going to cost us $287.80. Well, we can consolidate those into one database, and we can save some money that way. It's not a whole lot, but every little bit helps, especially when you're dealing with much larger scale than this. The second item is right sizing. We should really use the lowest cost resource that still meets the technical specifications. As an architect, you can design this into the landscape to make sure that we're using resources consistently and try to avoid spikes and valleys. Loosely coupled architectures are very useful in this case because they can smooth demand and create a more consistent and predictable demand profile than a bunch of spikes and valleys. You should also look at some purchase options. So AWS offers a few different types of purchase options where I can buy equipment at a better price than if I'm just using it on demand. If you have a permanent application and you know you're going to be running this instance for a long time, Reserved instances are probably going to provide you the best cost advantage there. Spot instances are really good for temporary horizontal scaling, yet another reason why horizontal scaling is preferred to vertical scaling. AWS has a concept known as EC2 fleets, and this allows you to define a target mix of on-demand, reserved, and spot instances to meet your needs. So if we look at M5 2X large, at the time of this recording, the on-demand price is 38 cents. If we decide to do a 1-year reserved, that drops it 40%. And if we want to use just a spot instance, that drops it to 7%. So that's a 79% savings over the on-demand. Now, AWS pricing can vary from region to region. This is something you might want to consider when you're trying to optimize your cost. If another region has a lower price and you don't require that service to be local to your current region, then you might be able to save a lot of money. And even if you are worried about latency, you can still use CloudFront and Route 53 to try to get around that. So if we take the example of S3 standard storage for the first 50 terabytes, US West 2 has the lowest cost per gigabyte. And you can see how the costs increase as we go to different regions. Now back to talking about those soft costs. If we're able to leverage some of the managed services that AWS provides to offload administrative responsibility, well, then that's a good thing, and that's going to drive our costs down. So for example, if we can use MySQL RDS rather than running MySQL on an EC2 instance, we're going to have a lower total cost of ownership. And we're going to gain that cost savings through not having to worry about the complexity or all the manual intervention that might be required. RDS, Redshift, Fargate, and especially MapReduce, setting MapReduce up manually is just a big hassle and a big headache. So using these fully managed systems can really help us lower the complexity and lower the cost. Now you should also think about data transfer because as you know, moving data into AWS doesn't cost anything, but moving data out and between regions does cost something because that could comprise a significant cost component for us if we're shuffling data around a lot. And in some cases, Direct Connect, although maybe on the surface it looks more expensive, it could actually be more cost effective in the long run, depending on what sort of data we need and our speed requirements. Okay, now we get to talk about one of my favorite features of AWS. It's tagging. Tagging is probably the number one best thing that I think you can do to help manage your AWS assets. And tags are just arbitrary name value pairs that you can assign to virtually all AWS resources, and it serves as metadata. And tagging strategies can be used for cost allocation, security, automation, and many other uses. For example, we can actually use a tag inside an IAM policy to implement a sort of access control for certain tagged resources. So let's say, for example, we have a whole collection of resources that is tagged to a certain department. We could create an IAM policy that leverages that tag and only give people who are a member of that department or that group access to those resources. And you can enforce tagging standardization a variety of ways. One way is just using the AWS config rules. You can set up some process that if an EC2 instance is not properly tagged, then maybe it's shut down at the end of the day. And most resources can have up to 50 tags, so that's quite a bit, and that's very flexible for us. Resource groups are somewhat related to tags because they use tags to group things into, well, resource groups. If we consider the example of maybe different departments having different collections of resources, we can create different resource groups based off the tags that we created and give members of those departments a customized console, a view into just their resources. And that's very useful, especially if you have a bunch of AWS resources out there. You can create a very focused, scaled down view for certain people. And some common examples of this, or maybe you do it by environment, by project, by resources allocated to a department or a cost center. And you can get to this in the AWS console. Up at the top, there'll be a drop-down called resource groups, and you can use the classic groups or you can use the new groups as well as a tag editor. AWS offers us a few different options if we want to buy resources in advance or just buy them temporarily. So we're going to talk about that now. The first is reserved instances, and that allows us to purchase or agree to purchase the usage of an EC2 instance in advance for a significant discount. And it also can provide reserved capacity when we specify an AZ. So in disaster recovery situations, if we want to make absolutely sure that we're going to have those resources in a disaster when we really need them, reserved instances tagged to an AZ is one way we can reserve that capacity and guarantee that. AWS Billing will automatically apply this discount whenever you launch an instance that matches the instance type or the family of your reserved instance. EC2 has 3 reserved instance types: standard, convertible, and scheduled. And you can also buy reserved instances on RDS as well. Now, if you have consolidated billing set up for multiple accounts, you can share reserved instances across those accounts, which is another benefit of consolidated billing. And if for some reason you find that you don't need your reserved instance, you can try to sell it on a secondary market called the Reserved Instance Marketplace. Let's look at the differences between a standard and a convertible reserved instance. Well, the terms are the same. You can do it 1 year or 3 years, and there's a variety of upfront payments, partial payments, or no upfront payments. Generally, you're realizing between a 40 to 60% discount on a standard, and you give up some of that savings on a convertible because convertibles are a bit more flexible. So on average, you're saving between 31% and 54%. So for both reservation types, you can change the AZ, the size, or the networking type via the console or an API call. One of the big differences, though, is that for a standard, you can't change the instance family or the OS or the tenancy. But for a convertible, you can change the instance family. And if over the term of the reservation, prices go down on that particular instance, you can realize that price reduction on a convertible, but not so on a standard. And presently, right now, only standard instances are saleable on the reserved instance marketplace. That's that secondary market. AWS says that sometime soon you're going to be able to sell convertible instances on the marketplace. So if we look at some of the attributes of a reserved instance, we have to define the instance type. That's just the memory, the CPU, the networking capabilities. We have to define what we want as far as a platform. Then we have to decide what we want as our tenancy, either shared or dedicated. And optionally, we can define an availability zone. Now, if we do happen to choose an availability zone, that reserved instance and that discount is only going to apply to that AZ. And that's called a zonal reserved instance. The benefit there is it creates that availability guarantee in that AZ that I was talking about before. If you don't choose an AZ, well, you get the flexibility to use that reserved instance in any AZ, but you don't get the guaranteed availability in any one AZ. And you can change back and forth between zonal and regional on the console or via API. So we have a reserved instance over here on the left, an M4 2X large, Linux, default tenancy, and we've chosen a availability zone, US West 2B. Amazon creates a reservation for us in US West 2B, and that's going to be discounted whenever we spin one up. And it's always going to be available. We're going to be guaranteed that compute power in that US West 2B. Now for a regional reserved instance, same machine type, but we haven't specified an availability zone. So we can use that in US West 2C. The difference here is it's not guaranteed. We're still going to get the discount. Now, additionally, we can get a discount on other resources that are in that same family. So we can spin up 2 M4X larges and realize that same discount. So a special note here is that instance size flexibility is only available for Linux regional RIs with default tenancy. It's not available for Windows, Red Hat, or SUSE. Let's talk about spot instances. At any one time, AWS has lots of excess capacity, and that's just due to the nature of the business. They don't know when we're going to ask for more resources, so they always have to have it available. But the genius here is they've been able to monetize that excess capacity on a market exchange basis. And so a spot instance process starts by a customer creating a spot request. You have to specify an AMI and a desired instance type and some other key information like a VPC and so forth. And then you define the highest price you're willing to pay for that instance. And if the capacity is constrained and others are willing to pay more, your instance might get terminated or stopped. And spot requests can be a one-time only, a maintain, or a duration based. One time only I call fill and kill. So it spins up a spot instance if your price is higher than the going rate, and it will get rid of that request. Maintain, on the other hand, will reprovision a spot instance if by chance the price rises too high and it gets terminated, and then the price goes back down below your maximum bid. Maintain will recreate another spot instance. Same thing goes if you go out and manually terminate it. A maintain spot request will make a new spot instance pop right back up. Duration based is a finite period of time. So for example, maybe I only need a spot instance for 3 hours, and I can set up my price, I can set up the duration, and then after that duration is over, my spot instance gets terminated and that request goes away. So for the one-time request, the fill and kill, whenever the price gets above my price point, the instance is going to be terminated and any ephemeral data I had there is going to be lost. But for the request and maintain, I can configure the instance to terminate, stop, or hibernate until the price point can be met again. So I don't necessarily have to destroy or lose my data. Here's a picture of market fluctuations on a certain instance type. In this case, it's a P3 8X large, and this is over a period of 3 months. And you can see there's the on-demand price. What's interesting here is the fluctuation independent of the availability zone. And usually what that means is that somebody took out a large position or a large request of P3 8X large instances for, in this case, availability zone US West 2B. And so that drove the price up almost, or at least approaching, the on-demand price. Whereas if I were to just go to a different AZ, that demand wasn't there, so the price remained low. This is an important point when thinking about architecting with spot instances, because the price and the demand can fluctuate between availability zones. And so thinking about architectures that allow you to spin up in any availability zone so you can really maximize the cost savings. Most of the spot instance pricing looks rather boring, more like this. This is a 3-month look at a T2 small. And sometimes if I want a cheap instance, I'll create a spot request and then specify some bid that's in excess of the on-demand price. That way I realize the benefit of the lower price most of the time. And I'm also covered if the price rises, because most likely all the other people are going to stop bidding once the price rises above the on-demand price. Let's talk about the differences between dedicated instances and dedicated hosts. Now, a dedicated instance is placed on hardware that's dedicated just for you. Now, that same underlying hardware may also support non-dedicated instances that are in your same account, but it's only going to be from your account. And dedicated instances are available as on-demand, reserved, or spot instances, but they incur an additional $2 per hour per region cost. Now, a dedicated host, on the other hand, is the physical hardware underneath, and you have control over which instances are deployed on those various dedicated hosts. And they're available as on-demand, or you can get a dedicated host reservation. And this is useful if you have some server-bound software license that needs to access cores or sockets or per virtual machine. Now, each dedicated host can only run one type of EC2 instance. So you can't mix and match instance types on a host. You have to run all the same type. And the capacity of the dedicated host varies depending on what EC2 instance types you're going to be running. So to summarize, dedicated instance is still a virtual machine. It just resides on hardware that you don't share with anybody else. A dedicated host is a physical machine that you can put your own instances on. Let's go over some cost management tools that AWS provides us. First, there's something called AWS budgets. This allows us to set up predefined limits and get notified whenever our spending exceeds or gets near that limit. We can set up budgets based on just pure cost usage or the utilization of our reserved instances. And one of the real important things about optimizing cost under AWS is being sure that we distribute the awareness of how much things are costing to run. And budgets are a very effective way to share that awareness with many people in your organization. We also have something called consolidated billing, and that allows a single account to be set up as the payer for multiple accounts. And the benefit here is that you're going to realize some economies of scale by consolidating your costs. Let's look at an example. Let's say we had three accounts, and each of these accounts has 50 terabytes of S3 storage that they have to pay for each month. If those were billed individually, we'd end up paying $3,450. But S3 has tiered pricing. So for the first 50 terabytes, it's one price. And then once we get over 50 terabytes, there's another price, a cheaper price. So if we consolidate these accounts together, we have a total of 150 terabytes of storage space that we're paying for. And our consolidated bill, taking advantage of that tiered pricing, is $3,350. Additionally, you also get the benefit of a higher aggregate bill, which might enable you more pull with AWS for certain credits or some negotiations. Trust Advisor is a very useful tool for a variety of reasons, but in the context of cost, it can point out where we're maybe missing some opportunity to save some money. And it's just a series of automated checks that can run on our resources. And it can recommend cases where we might be better off buying a reserved instance versus using an on-demand instance. Now, the core checks are available to anybody, and some more extensive checks are available to anybody with a business or an enterprise support plan. So in general, you need to know the difference between CapEx and OpEx, as well as fixed costs and variable costs. You should understand what TCO is, what ROI is, and the challenges faced with those activities. For cost optimization strategies, you should know conceptually the variety of ways that customers can approach optimization on AWS. And you should really fully understand the cost optimization pillar white paper that I referenced in the wrap-up section. For tagging and resource groups, understand the various common uses of tagging and ways which you can implement and enforce a tagging strategy. And you should know why and when you would create resource groups, and don't be tricked into thinking that resource groups are anything more than just a logical grouping. For spot and reserved instances, you should know the difference and the limitations for the different types of reserved instances, including zonal instances and regional. You should understand how spot instances work and what cases you would probably best use them in, and have a good understanding of dedicated instances and dedicated hosts and the differences between the two. For cost management, you should know how and when you would use AWS budgets, understand the benefits of consolidated billing. Also know that Trusted Advisor is something that can help you optimize costs. Remember to read through the white papers that I've linked in this lesson. If you're watching on a browser, they're going to be over here. And if you're watching on a mobile device, they're going to be down here when you put the device in portrait mode. Here are my pro tips for costing. Well, be extra careful around this TCO and ROI minefield. As General Akbar said, it's a trap. But if you're forced down the road of preparing a TCO or ROI analysis, definitely enlist the help of a finance person unless you happen to also be a finance person in addition to being an architect. Additionally, find ways to translate soft costs into hard costs. And one of the best places I've found for this is in academic research or studies. So Harvard Business Review and MIT Sloan Management Review have been two resources that I've used in the past very successfully because a lot of times they'll have articles in organizational change management, and they've gone to the trouble of quantifying some of those soft costs. So I can use that in my business case. Definitely be cautious about taking case studies or information from a vendor or somebody that has something to gain if your business case is successful, because that can undermine the integrity, or the perceived integrity at least, of your preparation. The real benefit of a cloud migration is in agility and flexibility, and cost savings really is typically not the strongest part of the business case. And so don't focus on cost as the sole reason for cloud migration, because you're going to get bit most likely, because when you first go to the cloud, your costs are going to rise because it's something different. It's more complex. It's unusual. Plenty of people will look at that and say, aha, I told you so. The cloud doesn't save any money. The problem is cost is a very malleable thing, and it can be sliced many different ways to support anyone's goals. I would focus instead on the gateway benefits of agility and flexibility. And those do translate into cost savings, but they also translate into customer happiness and the ability to respond to external or internal threats. And they also translate into innovation. Think of cost optimization as really more of a long-term effort. Be sure to set that expectation up front that initially costs are going to rise, but in the long run, we believe they're going to fall. And rather than laying down a bunch of overhead and rules out of the gate, let the team get a feel for AWS and the platform and give them some freedom. But one thing I do insist on is implement a tagging strategy right out of the gate so that when the time comes to rein in those resources, you have the groundwork laid and the good habits of tagging in place. If you're going to do a pilot project, I would recommend being very aggressive. Try to find something that has some large scale benefits. And don't be afraid to think big and impactful. Because if the benefit is large, then you're going to spend a whole lot less time debating the what ifs and the minutia because people will see that benefit, because that benefit will be very apparent. Okay, welcome to challenge number 1 of costing. I'm going to put a question here up on the screen. Pause the video and budget yourself 2 minutes, and then resume the video and we're going to walk through the answers. So here comes the question. All right, welcome back. One of the things I like to do with questions first is try to extract what we're really asking here. So I think there's a couple different points here. Number one, we're being asked to reduce costs, but we can't compromise the durability or integrity of the application. So those are kind of our bounds. So I'm going to start going through the answers here in no particular order. I'm going to kind of jump around just because that's what I feel like today. So option number A says, set up CloudTrail to collect usage logs to determine which instances can be scaled back. Well, the problem with this one is CloudTrail is a tool that monitors API access. CloudWatch is a tool that can collect machine statistics. So CloudTrail is the wrong tool here. So I can eliminate this one. Let's go to C. We can migrate an EC2-based DB2 database to RDS. Well, DB2 is not one of the supported database types for RDS, so we can really quickly eliminate that one. And just for kicks, let's go down to G. We can purchase a dedicated instance for those applications that are going to continue to be part of our roadmap for the next year. The question didn't say that we needed dedicated instances, so I can't assume that. And plus, dedicated instances do incur a premium price over regular instances. So I think I can safely eliminate this one. We'll go back up to B. We can configure our website's auto scaling group to use spot instances rather than on-demand instances. Well, this one sounds troublesome to me because if we just use spot instances in our auto scaling group, then it's likely that maybe the price of spot instances rises high enough to not allow us to scale. And so that could cause a problem for our durability or integrity. So a better option might be that we can use a certain number of reserved instances and then scale with spot. So I can eliminate this option. Option D says create a EBS snapshot lifecycle process to delete outdated snapshots. And yeah, that's a really good idea because that's one of the things that could incur cost is I have old snapshots out there that I don't need anymore. And so by purging those out, if I don't need them, I'm going to save some money that way. Option E says use S3's lifecycle feature to transition infrequently accessed data to different storage classes. And yeah, I think that's a good idea. And one thing to note here is that just by transitioning to a different storage class, we don't affect the durability of the data. It's still the same durability, whether it's in standard or infrequent accessed, for example. Option F says we're going to consolidate some small RDS instances into a larger RDS instance. Well, this may save some money, or it may not. We don't really know here. We don't have enough information to say that. And just provisioning something larger and putting smaller databases into it is not instantly going to save us money. So I'm going to eliminate that one. So the two options that I think sound most reasonable are D and E. All right, welcome to challenge number 2 of costing. I'm going to put a question up here on the screen, pause the video, budget yourself 2 minutes to answer that question, resume the video, and we're going to walk through the answers. So here comes the question. All right, welcome back. If I look at the question, there's a few things that pop out at me. First, it's this mention of occasionally we notice that the performance falls below acceptable levels. And so that tells me it's probably something that is tied to traffic that we can't necessarily predict. And we think it might be something to do with scaling. We're not able to scale fast enough. So let's start with the answers. Start up top. A, we could enable cross-zone load balancing on our ELB. Now, this is a good idea. Cross-zone load balancing makes sure that the requests are equally distributed across all targets, regardless of their AZ. So if by chance we scaled disproportionately, maybe we're using spot instances and we scale in one AZ more heavily because the price is lower, then we're not going to be able to fully utilize all those instances if we don't have cross-zone load balancing enabled, because otherwise the ELB is just going to do a round robin type distribution and allocate to whatever resources are available in the AZ that received the request. So this is a good thing, I think. Option B says we can purchase a dedicated host in US2 West and ensure that our instances are spun up in the auto-scaling groups, get assigned to the dedicated hosts. On the surface, this sounds like a good idea, but it's flawed in one important way. And that's that dedicated hosts can't be used in auto-scaling groups. And if you think about it, this makes sense because dedicated hosts have a finite capacity. And if we're trying to use it in an auto-scaling group, that kind of assumes that we have an infinite capacity. That's why dedicated hosts aren't supported, is because once we hit that capacity, then there's nowhere else to go. So I'm going to eliminate this one. Option C says we can purchase some scheduled instances for the most common poor performance times. This might work, but it seems we don't really have much of an indication around when the load might come. So I'm going to eliminate this one. Option D says we can submit a reserved instance modification request to move reserved instances from US East 2 to US West 2. Well, you can't move reserved instances between regions, so this just won't work. So I can eliminate that. Option E says make sure our VPC subnets have sufficient IP addresses. And depending on our subnet mass, if we have relatively small subnets, this might be a concern because if we run out of IPs, we're not going to be able to auto scale. So we might want to check that out. Now, option F says we can purchase some reserved instances without selecting a specific availability zone so the reserved capacity can cover all AZs. Well, this is flawed because if we don't assign that reserved instance to an availability zone, then we don't get that guaranteed availability. So this isn't going to help us at all. So the two answers I like most are A and E. Okay, hello Cloud Gurus. How y'all doing? You've made it to the end of this course. Congratulations. Let's take a look at the blueprint and see how far we've come. We started out in chapter 2 with data stores, and we covered items in these areas. Then we moved on to networking, security, migrations, architecting to scale. In chapter 7, we talked about business continuity, deployment and operations management in chapter 8, and finally cost management in chapter 9. So it does appear that we've done a pretty good job at covering the blueprint for the exam. But your journey doesn't stop here. From the very beginning, I've been endorsing a holistic preparation plan, and this includes white papers, forums, hands-on experience, practice, preparation, all that stuff. So you should definitely still follow up on that stuff. Some exam tips that I have: study to become an expert, not to pass the exam. Because then after you have that credential in your hand, you can speak with authority and confidence to clients and customers. And remember, start by eliminating the answers that don't work or are incorrect, because that'll really help you narrow down on the ones that are feasible answers. And avoid the practitioner's curse. Don't try to read too much into the question based on your own personal experience. You have to be sure to focus yourself just on the words in the question and on the words in the answer. And sometimes you have to put best practices aside if they don't line up with the answer to the question. And you should really dig deep enough into AWS to understand the why, not just the what. As I said from the beginning, the CSA Pro exam is all about the part after the because. You have to know why stuff is happening on AWS, not just what could happen. Definitely understanding is reinforced through application. And what I mean by this is roll your sleeves up, get out there on the command line or the console and build some of these use cases. I know, speaking for myself, I have to go through it and actually do the activity before I fully understand what I've been reading in black and white on a paper. And if you're a little bit unsure of your fundamentals, definitely go back and take some of the associate level ACG courses or practice exams. They're going to help reinforce some of those things that maybe you forgot. Go into the exam with a definite strategy. One of the things that we recommend is the understand, eliminate, evaluate, choose, and validate process that you're going to see in that AWS certification prep course that I've recommended. So let's take a moment to just do a little visualization exercise. And you're sitting in the exam room, you've done your best on that exam, you click that final submit button, and then up on the screen you're informed that you passed. That's going to be the best feeling in the world because you've worked so hard for this. And now you're part of an elite group of professionals that have one of the most valuable and most difficult to achieve certifications in IT. So think about that. You can do this. You will do this. And if you have to go back and repeat parts of this course, maybe after you take the practice exam, definitely do that. But I hope I've helped instill in you some confidence and some knowledge that you can walk in there and smash that exam. Good luck. I wanted to spend just a little bit of time talking about how you can continue to stay engaged and continue to learn on your AWS journey. One of the most valuable things that I think we can do to continue our education is share with others and learn from others. And at A Cloud Guru, we have a discussions forum, and specifically we have a discussions forum for certified solution architect professionals. So I recommend going out there, looking around, maybe doing some searches. You might find a solution to a problem that you've been having, or maybe you can post a problem that you're having and get the input of a bunch of different architects around the world. I also try to frequent the Solutions Architect Professional Forum quite a bit, and so you can definitely reach out to me if you have a question about the content or anything about the exam. One of the most difficult challenges I've had is just trying to keep up with the tremendous amount of new features that get rolled out almost on a weekly basis from AWS. So A Cloud Guru has put together a series called AWS This Week. And Ryan and Faye, two of our instructors, go through the week's happenings in new releases from AWS. It's very entertaining, it's very short, and it's a good way to keep up to date on AWS. Additionally, there's another reoccurring series that we call Release Review, and it's a little bit more in depth than AWS This Week. It'll take a new product, we'll do a dive into it, and see if it's something that we should use professionally, or maybe just let it set and let it age a little bit more. So that's really helpful if you're trying to determine all the things that are coming out for AWS. What can you use them for? Should you recommend them to your customer, and so forth? And finally, please feel free to reach out and connect with me on Twitter, LinkedIn, or GitHub. Thank you very much for watching my course, and hopefully in the future, maybe at an AWS event, we can connect in person and I can congratulate you on your CSA Pro certification.
Wow, what a ride. Well, this course has come to an end, but your journey doesn't stop until you smash that exam. So keep studying, keep practicing, keep going, but most importantly, keep being awesome cloud gurus.